Hello guys, welcome to AR Tutorials. Today is day 9 of solving LeetCode questions daily. Today we are not going to solve any LeetCode question. Just basically we are going to focus on the very basics of DSA. That is, today we are going to solve or see the merge sort. The merge sort has been the most optimal solution to sort an array because there are many types of sorting algorithms such as selection sort, bubble sort, and a quick sort, merge sort. Merge sort is a kind of a type amongst all the sorting techniques, which basically involves n log n time complexity, which is the most optimal amongst all, because the bubble sort gives you the n square complexity, which is one of the worstest complexities. But merge sort is considered to be the bestest because it uses the divide and conquer rule as well as recursion, and it only has the complexity of log n. So let's see how the merge sort works. So first of all, I'll tell you what the question needs and how we have to solve. We have given n as the size of an array and the array as 4 1 3 9 7. We have to sort this array into 1 3 4 7 9. Sorting can be done in any technique, but as the computer engineers, we only see the optimal versions. So here the optimal version would what be? The log n. Of course, the log n has the less complexity than n squares, and all. So the merge sort would be the perfect technique. Now I'll tell you how the merge sort is done. So suppose this is our array. Now we have to sort it. So merge sort works in divide and conquer rule. Now this has 8 elements: 1 2 3 4 5 6 7 8 9 elements, sorry. So what merge sort does, it divides an array into two equal parts. Now here are odd numbers, so what we will do, the left side would consist the great number of arrays, and the remaining part would be on the right side, such that this is our sorting factor. Okay, let's 1 minute. Okay, so this is our sorting factor, not this. Okay, so this would be our sorting element, in which this would be the first half and this would be the second half. Now what we will do, we'll again split this array into two parts. Now this has 3 and 2 ratio, so it will be the 3 elements would be there on the left side and 2 elements would be there on right side. So here we have 3 1, and here we have 3 1 2, sorry, and here we have 4 1. Then again the sorting algorithm would take place. So again the sorting algorithm will take place. Let me adjust my screen. Okay, so okay, then this was our then again we have to split. So here we have our splitting factors. Now we have to split from these 3 elements. Then what will be a splitting criteria? We'll first split into 3 1, and then we'll split into 2. Now here we will split into 4 and 1. Now in this part the splitting has been done completely. Now what we will do, we'll just make another split into this type, that is here it would be 3 so here it is 3 and 1, here it has become 2, here it is 4 and 1. Now one thing, if you have observed, we have reached toward the single element of each array. Now these are the single elements, we cannot divide it further. So what our merge factor does, we'll first traverse through the left hand side. First we'll reach towards the third element, then we'll go up till the first, then we'll go this side, then we'll see this side, then upwards, then this side, then this and then this. This is the backtracking procedure what we followed. Now I'll show you how neatly we can write it. Okay, so I'll change my color. So first this array will happen, then this will split into 3 2. Now when we'll reach 3, we'll go upwards and we'll see there are some elements. No, just we have 3. Then I'll traverse to the right side, then we'll go, the 1 will come. Now what we have here, we have 3 and 1. Now we'll do the comparison. If the lefter side is greater than the righter side, what we'll do, we'll swap. So it will become 1 and 3. So this will cut, and here we will have 1 comma 3. Similarly, we'll go towards upward in this direction, and we'll go, when we reach to this array, we'll go towards the right traversal 2 and till the bottom, till 2 here. So we see that it doesn't have any other sibling to be get compared, so this 2 will again come towards upward. Now what we have this 1 3 and we have came here 2. Now this element will be compared with this. We'll check if it is lesser, yes. Now the second element will compare with this. We'll check, no, this is smaller than me, so it should be before me, so they will swap. Then they will become as 1 2 3. Yes, are you getting what I'm telling? I'll first clean it everything, then I'll show. Okay, so when we came here, it was when we came here, this part was as 1 comma 3, but when 2 came here, it does not just merge or appends at the backward. It will compare to the rest of to the previous array and will perform the sorting. So what it will be? It will be 1 2 3 as per the sorting. So it will be as let me erase it first. Okay, then it has been 1 2 and 3. So I'll cut it down. Just I'll do 1 comma 2 comma 3. Then it will go to the main array. Our main array, this part to the, now we'll go for this part. Now 4 and 1, these all are children only of they don't have any siblings, so they'll both will get compared. As I told you, the right will be checked with left one. If left one is greater than right one, they'll swap the position, so it became 1 4. And again coming to the parent, we'll check each element with each one. So what we'll do, this all will get to the 1 1 2 3 4. Now this array is our left array. Now we'll go to the right array. Before that, I'll erase all everything. So we'll perform the similar thing of divide and conquer on the left hand right hand side also. Now this is our array. Now first what we'll do, we'll divide it. Now dividing it, it's in the equal parts only because 4 elements are there. First will there 5 2 and there it is a 6 4. Now 5 2 will be there as 5 and 2. Now here it became a 6 and a 4. Now for the comparison, what it will does, this first come to this part, this will go towards upward, and then this part will select as I'm sure that you must know the backtracking path. We are following the backtracking path. When these two will compare, this would be cut down, and after swapping we will get 2 and 5. Similarly here, these two will get compared and we will get 4 and 6. Now this and this would compare, and we'll get our final array as 2 4 5 6 on the righter side. Now when we'll compare this with this one, we'll get our final array as 1 1 2 2 3 4 4 5 6. Now this is our final array. What we have done by combining this array, we have compared this element with this element. If the left hand side is greater than the right hand side, we have swapped them. If not, we have just keep it as it is. So if this iteration is over, then we'll go to the second with the first one, and again all array elements will be compared to the all array elements. So this is our final answer. Now we'll see how the code we should implement it. Okay, so the code is very simple. First we have to use the recursion. So while using recursion, what we will do, we will first check if low is greater than or equal to high, such that we have some elements in an array. If not, we'll directly return, we'll break that, such that when high crosses the low or low crosses the high, we have to return. In second, what we have done, we have to find mid index. So we are splitting from the mid index, as I have told you. So finding mid index is very crucial. So if we find index, what we have done, we have made it into two sub arrays. One is from low to mid, and second one is from mid plus 1 to high. So we'll just split this to the merge. This is called recursion, calling function inside a function until and unless a specific condition is occurred is called as a recursion. So this is our base condition, if condition, and we have splitting it till our base condition is occurred. So first we have passed our array, then from low to mid, and again then mid plus 1 to high we have one. So it will split until only single elements would not be there. Then we will run the merge function is the main function. So what we have done, we have stored the first element of each arrays into the left and right. So left will consist the low and right will consist the mid of one. Now we have created a vector to store the sorted array. So what we will done, we will first do if the less is less than mid, such that there is something inside a left. If left is equal to mid, which means they have one element. If left is less than mid, there are multiple elements. Similarly for the right, if what we'll consider here, if array of left is less than array of right, as I have told you that if left part is less than the right part, we have to just push back. Pushback is the function in the vector, so we have to just push back and we have to increase the counter of left. And else part is such that we have to just first what we have to do, we have to push back the right element and then the right plus plus. Then what we have to do, while condition, again if there are elements in left array and the right array has been submerged, so we have to put all the elements of left array inside the our answer. So we will just put the answers and do left plus plus. Similarly for the right, we will do right plus plus. And again we have done from high to low to high loop, and we have just pasted all the elements of temp into the array. This is our code. It is very easy code. Just try it once, you will find it very easy, and it is the most optimal code of merge sort, and merge sort is the most optimal. So we have got the expected answer. So thank you guys for watching this video, and please do like, share, subscribe to my channel. I'm new to this channel, please support me. Thank you.